This task is from our writing and graphing linear equations unit, focusing on the lesson that is for perpendicular lines. As you can see from the task, we have one similar to our parallel lines task. We have two different lines intersecting, and we want students to analyze the graph and be able to write the equation for each line in slope-intercept form. After they do this, we have a few things we want them to consider. With the blue line, we can see that we have a rise of 2 and a run of 3 with a y-intercept of 3. This would give us the equation y equals 2 over 3x plus 3. The green line has a rise of 3 and a run of 2 with a y-intercept of negative 5. This gives us the equation y equals negative 3 over 2x minus 5. So now we need to look at the questions. What type of lines are these when you look at them together? And what is the same about the equations? So things that we got right off the bat were, well, they're intersecting lines. We really didn't hear the term perpendicular at this point necessarily, maybe just a handful of students. They mentioned that it was linear, and some students did mention that the rise and run were using the same numbers. One thing we want to prompt students with during the consolidation piece is what was the connection between the slopes? So we really want them to just ignore everything else and focus on the two slopes that we have. So we have 2 over 3 and we have negative 3 over 2. And that's where the students will mention, well, the rise and the run are flipped, and then one is positive and one is negative, because we kind of want to focus on that piece before we move on, because we're going to look at a Desmos example, which kind of shows us what happens when we multiply the slopes together. The product of the slopes for perpendicular lines should always get to negative 1. Pulled up here, and it is the lines 2-point form. Now you can click on those 3 lines and open it up through that list. All of these rows auto-populated except for row 9. That is one of the equations from our task, and I entered that in. So this line right here that has the 2 blue points on it, that is what auto-populates. And then this one is the one that I typed in row 9. And what we can do is we can manipulate one of the points on here to try to get our slopes or our equations to be pretty much what we consider perpendicular. Now, when we do that, you're going to notice what happens with the slope. This ties in and shows us a relationship that two perpendicular lines, if you multiply their slopes, you will get a product of negative 1. Pulled up. One misconception that we ran into was students thinking that every line that intersects another line, their slopes have to be negative reciprocals of each other. So that was something we ran into the first time we went through this and realized that we needed to make sure we touched on that in our consolidation piece. So part of what we did is we used the Desmos graphing, and we showed them that we can have two lines intersect. And if you notice the equations on the left side, both of those slopes are positive, and they're definitely not reciprocals of each other. So we just want students to understand that when we say it has to be negative reciprocals of each other, we're specifically talking about those perpendicular lines. Okay, so in order to intersect at 90-degree angles, the slopes must be opposite signs, meaning one slope is positive, one is negative, and the rise and the run are flipped.